Hello. In this recording, we will continue in Chapter 6. This time, we will cover mutual inductance. I'll do a little review of mutual inductance since we did cover that in class, and then I'll do a couple problems. As we talked in class, mutual inductance is when a magnetic field is created by this inductor, one inductor, L1 or L2. Let's talk about L1. And L1 envelopes L2 and creates a mutual inductance. Likewise, L2 envelopes the magnetic field created by L2 also envelopes L1 and creates a mutual inductance. So we had said the voltage induced by inductor 1 or across inductor 1 was equal to the self-induced voltage caused by the current going through inductor 1 and also mutual inductance caused by the current in going through inductor 2. And voltage 2 is equal to the inductance caused by the current going through inductor 2 plus or minus the mutual inductance created by current 1 enveloping the magnetic field caused by current 1. So the first part is the self-inductance, voltage caused by self-inductance, and the second is voltage caused by mutual inductance. And how does the sign get determined? How do we know if it's a plus or a minus? We know that from the dot convention. When the reference direction for a current enters the dotted terminal of a coil, the reference polarity of the voltage that it induces in the other coil is positive at its dotted terminal. Another way of saying this is when the reference direction for a current leaves the dotted terminal of a coil, the reference polarity of the voltage that it induces in the other coil is negative at its dotted terminal. So let's take a look at the four different situations that we had set up. The first one is when the dot is at the top of L1 and at the top of L2. In this case, we're looking at voltage 2. So let's draw our current in I1. And this current is entering the terminal. So it's positive at the dot. So this aligns with our reference for our voltage, which means that V sub 2 would be equal to its self-induced voltage caused by current 2 plus the mutual induced voltage caused by current 1. Okay, our second example. The dots at the top with inductor 1, at the bottom for inductor 2. Our current remains the same in all these cases. We're going to give it the same direction. Okay, and V2 we'll keep the same reference for the polarity of voltage 2. Okay, in case number 2, our current is entering the terminal, so we will put a positive at the dot on our second inductor. And we can see that our reference polarities are opposite. So voltage 2 is the self-induced voltage caused by current 2 minus the mutual induced voltage by current 1. All right, example 3. So in this example, current 1 is leaving the dot. So we put a minus at the dot, a minus at L2's dot. And as you can see, our polarities are opposite. So when we write our equation, voltage 2 is self-induced voltage minus the mutually induced voltage by current 1. Our last example, we'll put the dots, both dots at the bottom. So voltage 2, well, let's take a look at our polarity. Current 1 is leaving, so we will put a minus. Our polarities align. So voltage 2 will be the induced voltage plus the mutually induced voltage by I1. Okay, let's do an example. Example 6.8. Use the mesh current method to write equations for the circuit below for I1 and I2. Okay, in this example, we have two unknowns. Therefore, we need two equations. Okay. Apply Kirchhoff voltage law at mesh 1. Okay. Let's set up our polarities here. All right. As I1 approaches the 5 ohm resistor, there is also the current from I sub G going through the 5 ohm resistor. So we set up our voltage drop as I1 minus I sub G. Now we approach our 4 Henry inductor. So it'd be 4 Henrys plus the change in current I1 over time. So this is our self-inductance. All right, now we need to know, is it plus or minus the mutual inductance? The 16 Henry inductor is causing a mutual inductance of 8 Henrys with the 4 Henry inductor. To choose our sign convention, we determine the polarity of how we're going to write this. So are we going to say I sub G minus I sub 2, as the book does, or I sub 2 minus I sub G? If we said I sub 2 minus I sub G, then what is our sign? I sub 2 is the dominant, so this would be plus and this would be minus, which would make this a minus and this plus, which is opposite of our polarity that we've given. So we would say minus 8 di2 minus dt minus g I sub g over dt. Okay, now let's take a look if we made I sub g the dominant. Okay, let's change the color to blue. So if I sub g is the dominant, determines the polarity of the voltage across this inductor, then it would be a plus because I sub g is entering, so we would have a plus here, in which case it would be plus 8 d I sub g minus I sub 2 over dt. Okay, let's move on. So I sub 1 now enters the positive terminal of the 20 ohm resistor, so it'd be 20 I sub 1 minus I sub 2 equals 0. All right, let's take a look at our second mesh equation. Apply KVL at mesh 2. And let's erase all this. Okay. Okay, let's have set up our polarities here. All right, and let's start with I sub 2 entering the 16 Henry inductor. So that would be the self-inductance, 16 Henry, derivative of I sub 2 minus I sub g over dt. And are we going to do, let's take a look. So this one, we only have I sub 1 going through this inductor. So, and it enters at the positive terminal. So, or it enters at the dot. So we put a plus at this dot. And you'll notice that our polarities do not align. So we will say minus 8 Henry, which is the M value, the mutual. And the derivative of I sub 1 over dt. Okay, now our current moves to the 20 ohm resistor, 20, and this time it's going to be I sub 2 minus I sub 1, and plus 60 I sub 2. Okay, part B. Verify that if there is no energy stored in the circuit at t equals 0, and if I sub g is equal to this, the solutions for I1 and I2 are this. Okay. Let's see. Be nice if I could copy that, but all right, B. Oops. So no energy is stored at I equals 0. All right, so we have I sub g is equal to 16 minus 16 e to the minus 5t amps, and at 0 it would be 16 minus 16 e to the minus 0, which is 1. So I sub g would be 0. And at infinity, I sub g of 0 is equal to 16 minus 16 e to the minus infinity, which is 0. So it'd be 16 amps. And I sub 1 is equal to 4 plus 64 e to the minus 5t. You know what, I'm going to move that down a little bit because it's kind of running into each other. Plus 64 e to the minus 5t minus 68 e to the minus 4t amps. So I sub 1 at 0 is 4 plus 64 e to the minus 0, which is 1, minus 68. And that would give us 0 amps. And I sub 1 at infinity is equal to 4 plus 64 e to the minus infinity minus 68 e to the minus infinity, which would give us, this would be 0, this is 0. So that would be 4 amps. Okay. I sub 2 of t is 1 minus 52 e to the minus 5t plus 51 e to the minus 4t amps, and I sub 2 of 0 is 1 minus 52 e to the minus 0 plus 51 e to the minus 0, which is 0. And I sub 2 at infinity is 1 minus 52 e to the minus infinity plus 51 e to the minus infinity. This is 0, 0. So that would give us 1 amp. Okay, so if we look at this circuit up here, as t approaches infinity, the source, let's write this out here. As t approaches infinity, the source approaches a steady DC current of 16 amps, which we found down below. Okay. So when that's the case, well, let's see, when that's the case, to a DC source, our inductors become short circuits. So let's redraw this circuit with our DC source. So we would have our current source, which is 16 amps. We would have our 5 ohm resistor, our 20 ohm resistor, our 60 ohm resistor, and this is a short circuit here and a short circuit here. Okay. So we have node A, which is right here. And we have this short here. So let's redraw our circuit. Okay, so all right, if we extend this right here, then we can bring our 5 ohm resistor here. And we're now at this point. We have our 20 ohm resistor here and our 60 ohm resistor here. So this is node A, and this is where we have this short. Okay. So we can find our equivalent resistance. Our equivalent is equal to 1 over 5, well, 1 over our equivalent, plus 1 over 20, plus 1 over 60. And that will give us our equivalent is equal to 3.75 ohms. And let's redraw the circuit. So we have 16 amps and 3.75 ohms. So our voltage here is 16 times 3.75, which is 60 volts. So we have 60 volts. Okay, if we look at our original circuit, where is I1 coming in? If we redraw here, I1 would be redrawn right here, and I2, maybe I should make it a new color here. I sub 2 is right here, and then we have a current I sub 20 and I sub 5, and this is I sub G. All right, well, we want to find I sub 1 and I sub 2. So let's take a look at I sub 1. KCL I sub 1 is equal to I sub 20 plus I sub 2. Hang on a second, let me make sure I'm in the right place. Yes, I am. Let's add a page here. Okay. Okay. So I sub 1 is equal to 60 volts over 20 plus 60 volts over 60, which is equal to 3 plus 1, which is 4 amps. And I guess I should clarify that this is at infinity. So given the original equation here, we found that I sub 1 at infinity is equal to 4 amps. So the original problem asks, verify that if there is no energy stored in the circuit at t equals 0, the solutions for this, so that verifies. Okay, KCL for I sub 2. So I sub 2 at infinity is equal to the voltage, 60 volts over 60 ohm, which is equal to 1 amp. And from our equation above, we found I sub 2 at infinity is 1 amp, so that checks out. Okay. Guess I didn't need this extra page here, so Let's say goodbye to that. Delete page. Okay, and let's move on to the assessment problem. Assessment problem 6 is very similar to the example problem, but instead of verifying by plugging in, we are actually going to satisfy the differential equations derived. Okay, write a set of mesh current equations for the circuit in example 6.8 if the dot on the 4 Henry inductor is at the right hand terminal. 4 Henry inductor. Okay, so we're changing this dot and we're saying it's on the right hand terminal. The reference direction of I sub g is reversed. So I sub g is now going in this direction. And the 60 ohm resistor is increased to 780 ohms. Okay. All right. KCL mesh 1. We'll approach it the same way where we're okay. So let's go to the 5 ohm resistor is I1, and this time I sub g is going in the same direction as I sub 1. So plus I sub g, and then we come around to the inductor. So it'd be plus 4 henries and di1 over dt. All right, now the mutual inductance. Okay, so I sub g is leaving, and I sub 2 is also leaving. So if we put a minus here, then we'll have a minus here and a plus here. And the polarities align. So it would be plus 8 derivative of I sub 2 plus I sub g over dt. And we move to our 20 ohm resistor, so plus 20 I sub 1 minus I sub 2 equals 0. All right, let's clean this up a little bit. So 5 I sub 1 plus 5 I sub g plus 4 di1 over dt plus 8 di2 over dt plus 8 di sub g over dt plus 20 I sub 1, oh, sorry about that, minus 20 I sub 2 equals 0. Okay, let's combine everything. So I sub 1, 5, 25 I sub 1. And let's put these guys together, plus 4 di1 over dt minus 20 I sub 2 plus 8 di sub 2 over dt. And let's put I sub g on the right side, so that would be minus 5 I sub g minus 8 di sub g over dt. Okay, KCl mesh 2. So let's erase all this. Oops. We didn't want to erase all of it. So I sub G is going in this direction, and this is 780. Okay. Okay. So all right. Well, let's start with the 780 ohm resistor. Okay. I sub 2 enters the 780 ohm resistor. So we'll make this plus, minus, plus, minus, plus, minus. Okay. Then it approaches the 16 Henry self-inductance is I sub 2 plus I sub G, because they're both going in the same direction, over dt. Now, let's look at the, let's see, needed to change this. So I sub 1 is leaving, so that's a minus at the dot, and we'll put a minus at the dot here. So our voltage polarities align here. So we will say plus 8 derivative of I1 over dt plus the 20 ohm resistor times I sub 2 minus I sub 1 equals 0. So we have 780 I sub 2 plus 16 di sub 2 over dt plus 16 di sub g over dt plus 8 di sub 1 over dt plus 20 I2 minus 20 I sub 1 equals 0. And let's clean this up a little bit. Minus 20 I1 plus 8 di1 over dt plus 20 I sub 2. Oh, plus, okay, so plus 780 I sub 2. So that would be plus 800 I sub 2 plus 16 di sub 2 over dt is equal to, we should have another I sub g. No, I guess not. Is equal to minus 16 d I sub g over dt. Okay. So these are our two equations. All right, so B, verify that if there is no energy stored in the circuit at t equals 0 and I sub g is equal to this, and I sub 1 and I sub 2 are equal to this. Okay, we're going to do this by seeing that they satisfy the differential equation. So we're going to do this a little bit differently. So we have I sub g is equal to 1.96 minus 1.96 e to the minus 4t, and let me so derivative of I sub g over dt is equal to 0 minus 1.96 times 4 e to the minus 4t, which is equal to 7.84 e to the minus 4t. Okay, I sub 1, let's give it another color. I hope you're okay with all these colors. I sub 1 of t is equal to minus 0.4 minus 11.6 e to the minus 4t plus 12 e to the minus 5t. Derivative of I sub 1 over dt is equal to 0 minus 11.6 times minus 4 times e to the minus 4t plus 12 times minus 5 e to the minus 5t. So that will give us let's see, 46.4 e to the minus 4t minus 60 e to the minus 5t. And then I2, let's change our color. Grab a new color here. I sub 2 is equal to minus 0.01 minus 0.99 e to the minus 4t plus e to the minus 5t. So di2 over dt is equal to 0 minus times minus 4 e to the minus 4t plus 1 times minus 5 e to the minus 5t, which is equal to 3.96 e to the minus 4t minus 5 e to the minus 5t. Okay, so we have all of these. Let's plug them in to these two equations. And verify. All right, verify mesh 1. All right. So we have minus 20 Why do I have 25? Oh, it is 25. Okay. Mesh 1. So it's 25 I1. So 25, and then I1 is minus 0.4 minus 11.6 e to the minus 4t plus 12 e to the minus 5t. Then it's minus 20 I2. Minus 20, and I2 is minus 0.01 minus 0.99 e to the minus 4t plus e to the minus 5t plus, oh, I should have put these together. Oh well. plus 4 di1 dt. So that's 4 times di1 dt, which is 46.4 e to the minus 4t minus 60 e to the minus 5t, and plus 8 di2 dt. So that is 8 times 3.96 e to the minus 4t minus 5 e to the minus 5t. And we said that was equal to minus 5 ig, so minus 5. And I sub g is 1.96 minus 1.96 e to the minus 4t, and minus 8 di dg, which is 7.84 e to the minus 4t. Okay. All right, so I'm actually going to go back to the order that we had, but let's see. This will give us, I'm going to use another color just to make it easier to see. So 25 times 0.4 is minus 10 minus 290 e to the minus 4t plus 300 e to the minus 5t. And then I'm going to go to, so I'm going to do this one, and now I'm going to do this one. So that's plus 185.6 e to the minus 4t minus 240 e to the minus 5t. And now I'm going to do this one. So that's plus 0.20 plus 19.8 e to the minus 4t minus 20 e to the minus 5t. Okay, and now let's do this one here. So that'd be plus 31.68 e to the minus 4t minus 40 e to the minus 5t. And all this is equal to, let's do this one, minus 9.8 plus 9.8 e to the minus 4t minus 62.72 e to the minus 4t, which is this right here. Okay. All right, so let's find all of our constants. So minus 10 plus 0.2, and yeah, so we will make that minus 9.8, and on this side it's minus 9.8, and now let's find everything that's e to the minus 4t. So this is minus 290 plus 185.6 plus 19.8 plus 31.68, and that should give us minus 52.92 e to the minus 4t. So if we add these two up on this side, that's minus 52.42 e to the minus 4t. Okay, now let's do e to the minus 5t. So 300 minus 240 minus 20 minus 40 is 0. Okay, so we have just verified for mesh 1 that they are both sides equal. All right, let's verify mesh 2. All right, so we have minus 20 I1, which is minus 0.4 minus 11.6 e to the minus 4t plus 8. We're using, by the way, this equation here. Plus 8 di1 over dt. So we said di1 over dt is 46.4 e to the minus 4t minus 60 e to the minus 5t plus 800 I sub 2. And I sub 2 is minus 0.01 minus 0.99 e to the minus 4t plus e to the minus 5t. Okay, plus 16 di2 over dt. Plus 16. So that is 3.96 e to the minus 4t minus 5 e to the minus 5t. And we said that that is equal to minus 16, the derivative of I sub g over dt, which is 7.84 e to the minus 4t. All right, so let's clean this up and multiply through on everything. So minus 20 times minus 0.4 is 8 plus 23, 232, excuse me, e to the minus 4t minus 240 e to the minus 5t plus 371.2 e to the minus 4t minus 480 e to the minus 5t minus 8 minus 792. I'm going to put that down there. 792 e to the minus 4t plus 800 e to the minus 5t plus 63.6, 63.36 e to the minus 4t minus 80 e to the minus 5t equals minus 125.44 e to the minus 4t. All right. Let's find all of our constants here. 8 minus 8 is 0. Now let's do e to the minus 4t, so 232 plus 371.2 minus 792 plus 63.36, and that gives us minus 125.44 e to the minus 4t. And that's what we have on this side. All right, and then our last, e to the minus 5t. Let's see, minus 240, minus 480, plus 800, minus 80 is 0. Therefore, we have verified both meshes. And that concludes this recording. It also includes Chapter 6. I was going to do another problem, but I think these recordings are pretty long, so this is good.